I'm very pleased to have been invited to present this information. That's what it is, information as to what's going on here. So, before we start on the information, and there's a lot of it, so we're going to concentrate a bit, I would just like to welcome friends, fellow seekers after the truth, and skeptics. Because we're all true skeptics here. We're skeptical when we're told UFOs don't exist. We're skeptical when we're told all crop circles are man-made, and we're certainly skeptical, I hope, when we're told vaccines are safe and effective. So this particular subject, which may well be, and has been called, the most significant technological event in the 20th century, the landing of humans on the moon, 12 of them, named astronauts, on the moon, the most significant technological event of the 20th century, and I'm going to possibly cast doubt on it, because I'm skeptical when I'm told to believe something. I believe in Father Christmas, the Tooth Fairy, and God. For everything else, I want evidence. That's what we're going to be looking at. Now, you're probably going to have a few questions for me at the end of this. So I want to ask you a few questions now. Will anybody here who believes in psychokinesis please raise my hand? Who did that? Thank you. Oh, I do love scientists around me. Now, I watched the Apollo moon landings. I watched them live on television. I wanted it to happen. It was a great historical moment. Historic moment. Get the English right. For 25 years, I believed it happened. And then I looked at the evidence. Can you focus the evidence? You can't have the evidence going out of focus. I don't know why it keeps going out of focus. It's Anyway, don't worry about it. When I started looking at the evidence, that's when the doubt started. So today I will show you what I found and see if you agree with what I found. And please, if you think I'm wrong, please tell me. I want to get on to something else. I've been doing this for 12 years. Nobody has convinced me yet that what I'm about to show you tonight is wrong. I hope there's somebody here who can do it. I was trained as a photographer in London in the 60s, and it said that if you're in London in the 60s, you don't remember what happened. I do. I was trained as a photographer. I know what cameras can and cannot do. I've used the Hasselblad cameras, similar to those used on Apollo. We'll look at those later. I've examined a replica of the lunar cameras used by the Apollo astronauts. But proving that the photographs and the films presented by NASA as evidence for the moon landings could not have been taken on the moon, as the photographs and films could not have been taken on the moon, does not prove that no one has been there. It just proves that what we have all been told happened is not the whole truth, and that's the key point. But it also allows NASA to live up to its other name of never a straight answer. So what is true, real, and provable about the Apollo moon landings? Now, why is it important? Why is it important to look at this? Surely, you're going to tell, look, this happened 35, 36 years ago. It's history. We all know it happened. What are we doing here discussing it? Right, it is important. Another question. Do you believe everything your government tells you about everything all the time? No, thought not. Anybody here believe everything their government? No, I don't think so. Right, where do you draw the line? Where's the line in the sand? Where do you stop? Where do you stop and say, I believe that? Because there will be things your government tells you that are true. Drive on the left is one of them. It's surprising. There are things we all agree with that would be helpful if we did, and if we didn't, we're going to get into serious trouble. But there are some things your government tells you, don't mention weapons of mass destruction, don't mention those things, that your government will tell you that are not the whole truth. Some of them get sexed up a bit. Some of them get spun a bit. Some of them are politically charged and require you to believe one thing rather than another. Just because the Apollo moon landings are a scientific achievement doesn't make them any less political. They were an extremely political event. That's the first change in attitude. Look upon them as a political event. We'll see why in a minute. Now, some more questions. It's a multi-part on this, so I'm going to give you 4 options, and you're only allowed to choose one. First part. The named Apollo astronauts, that's Aldrin, Armstrong, Mitchell, Shepard, Cernan, Schmidt, Scott, the rest of them. The named Apollo astronauts all landed and walked on the moon. That's the first one. Second one. Someone has landed on the moon, but we don't know who. Third part. No human has been anywhere near the moon, let alone walked on its surface. Fourth part, don't know. Okay, first part. 12 unnamed Apollo astronauts have all landed on and walked on the lunar surface. Who believes that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Someone has landed on the moon, but we don't know who. Who believes that? 1, 2, 3, 4. Oh, a few more. Okay. No one has landed on the moon. Who believes that? 1, 2, 3, 4. Okay. And the rest of you presumably don't know. Alright, there is a majority who believes that some human, named or otherwise, has landed on and walked on the lunar surface. Fair enough. It could well be true. Where's the evidence? What evidence would you put forward to me to support that contention? Well, I'll tell you what evidence we put forward. It's the evidence I'm about to show you now. It's the photographs, the films, the astronauts, the books, the magazines, and the several billion people who believe it. That's the evidence. Where does that evidence come from? NASA. It doesn't come from anywhere else, because NASA had total control over the issue of all information. Oh, but you'll say, that's National Geographic, that's an independent, that's not owned by NASA. No, it's not. National Geographic happens to be the world's best-selling magazine, or it was in December 1969. National Geographic paid NASA and the astronauts, as Life magazine did, paid the astronauts for an exclusive of their story. The astronauts had total editorial control over what was written or photographed about them, which is an extremely unusual event. Now, why is it important that we look at this? It's important because if it was so easy back in 1969, when the computing ability was much smaller than it is now, there were no digital cameras, everything had to be done manually. If it was so easy back in 1969, why haven't we been back? The reason is that space travel is very dangerous. 200 miles above the Earth's surface, where the space station flies, is a very alien environment for humans. Now, if we have been misled as to how easy it was, and how simple it was, and what wonderful people the Americans are, which in many cases they are, they make it after all, why don't we continue? George Bush, I believe, has recently announced that we're going to return to the moon and Mars, and travel to the stars, and whatever he wants to go. And when are we going to get back to the moon, according to George Bush, in the 21st century, 35 years after Apollo? We're going to take twice as long to get back as we did to get there in the first place, with 21st century technology. Hang on a minute, what's going on here? Is it that difficult to get to the moon in the 21st century? Obviously it is. So what was it like in the 1960s? Very easy, wasn't it? Terribly easy. 12 guys got there. Lots of people flew up to the moon, and we even had a bit of a drama with Apollo 13, who didn't get there. Now, let's get real at this point. Space travel, as I said, is a very dangerous undertaking. Why was it that Sean O'Keefe, when he was head of NASA 3 years ago, stated he had two major objectives for his term in office. One was the development of advanced propulsion systems to ensure that man could travel to the outer planets of the solar system. Fair enough. Probably nuclear-powered propulsion systems, ion drives, need to be developed if you're going to get anywhere beyond the solar system. And the second part of his time in office was going to be developing the protection for astronauts from the dangers of radiation in space. Hello? They got to the moon 30 years before. Why are we still investigating how dangerous it is to travel in space? Ah, because the moon is so near and Mars is so far away that it's much more dangerous to go to Mars, which is where we're going. No, we're going to the moon first. So why do we need to investigate the dangers of radiation in space? Because radiation, certain types of radiation, specifically solar flares, kill you. End of story, you're dead, gone. When you be with the dentist and have a tooth x-ray, you'll get into a little room and the technician operating the equipment will put a lead apron on or preferably get out of the room because radiation is cumulative in the human body. This is not to get into what radiation will do to photographic film. We'll come to that later. In my contention, the evidence for the moon landings is at best seriously misleading and at worst is fabricated. Now, there are many subjects involved in this. There are many people involved in this. And a great deal is at stake. If you're not being told the truth, how do you know what to believe? You don't. You read Nexus. That's how you find out. And anybody who hasn't read Nexus, you've got a treat in store over there. Special price, £2.50. Okay. Now, what I'm going to talk about has nothing at all to do with waving flags, odd shadow angles, no stars in the pictures. Nothing to do with that. We might talk about the rocks, the Russians, the reflections. But it has everything to do with temperature, pressure, and radiation. What is the temperature of space? Temperature of space. Minus 273 degrees Celsius. It's the temperature at which all molecular action ceases, i.e. nothing moves. You won't have experienced that temperature. Space has no temperature unless you put an object in space, in which case it will have a temperature. A spacecraft, for instance, planet Earth, the moon, anything else in space will have a temperature if it is exposed to the radiant energy of, in our case, the sun. How much energy does the sun put out? The solar constant, excuse me for the technical stuff, but it's not necessary to get the overall picture. The solar constant is 1,350 watts per square meter per hour. That's how much energy falls on the surface of the sun, from the sun onto the earth. And similarly onto the moon. I.e., quite a lot. It's like me standing in front of a 1-bar electric fire. That's how much energy the sun produces. It's absorbed through the atmosphere, it's absorbed into the earth, but that is how much energy. So if you go up into space in your spacecraft, and you get out of your space shuttle, which happens to be at about 200 miles up, which by the way is totally real, as are all the astronauts in the space shuttle, as is the space station, totally real, no problems there. If you get out of the space shuttle, and you do a bit of work, which is what you're supposed to do on the space shuttle, and you fly around into the shadow of the Earth, what's the temperature then? Minus 150 degrees Celsius. Because there's no heat. There's no atmosphere, so it's not being absorbed. It's not like we've got atmosphere all around us here, so the heat dissipates. It's like a big blanket today. But the atmosphere generates and dissipates the heat. Now, if you go into the shadow of the Earth, you've got no heat whatsoever. And in the space shuttle, the astronauts were complaining how cold their hands got, and they had trouble working. And they're only in the shadow of the Earth for about 40 minutes before they come out in the sunshine. So NASA asked them to conduct some experiments. You think they'd have thought about it before they said, no. They had to do it about 10 years ago. Well, they go in the shadow of the Earth, minus 150 degrees Celsius, as they come out of the shadow into the sunlight, and this is an exact quote from Michael Foale, who was the British astronaut who did the experiment. Within a few minutes, the temperature is plus 250 Fahrenheit. Just short of boiling point of water. So in other words, it's hot. But they're wearing their big spacesuit, they know they're frying. And NASA, in their wisdom, gave them an electric heater so they could span up the Hubble telescope and all the other bits they had to do. The point about that story is that it's cold and it's hot. And if you're in the sun, it's hot. And if you're in the cold, in the shadow, it's cold. And there's no in between. Because there's no atmosphere to dissipate. So you've got temperature, you've got pressure. What's the pressure in space? Nothing. There is no pressure. It's a vacuum. Man can't live in a vacuum. You take your spacesuit with you, it gives you a vacuum, it gives you a pressure inside, 5 pounds per square inch. Which doesn't sound very much, because the weight of air above each of us is 14 pounds per square inch. Quite a lot. When you get into your spacecraft and you pressurize it, so then you take your spacesuit off and live comfortably and breathe the atmosphere, 5 pounds per square inch, again, doesn't sound a great deal until you extrapolate it up to pounds per square foot, where it comes out at over 700 pounds per square foot. 700 pounds per square foot is a third of a ton per square foot. That's quite a lot. Have you ever been run over by a car on the track? A bit painful. That's even less than 700 pounds per square inch, or per square foot. And we'll look at some of those craft that managed to get up to the moon, and we'll ask how on earth they managed to withstand that internal pressure. Built the way they were, shaped the way they were, because they were nowhere near the correct shape to withstand that type of internal pressure. And the third item, we have temperature, pressure, we've got radiation. 200 miles above the Earth's surface are what's called the Van Allen radiation belts. They are belts of radiation that are concentrated by the Earth's magnetic field, so that the solar radiation, which is all the electromagnetic spectrum, X-rays, gamma rays, visible light, radio waves, the whole lot, generated by the sun, anything generated by the sun, some of which we want, visible light, some of which we prefer not to have, gamma rays and X-rays, some of which we can't do anything about, cosmic rays, but the Van Allen belts protect human life and life on Earth to a great extent from the dangers of radiation in space. It varies, it goes up, it goes down. We've heard of the solar maximum, that's where the sun is its most productive. So when you go beyond the Van Allen belts, i.e. more than about 20,000 miles out from the Earth, and the moon is 250,000 miles away, you're going to be exposed to all the radiation that the sun can generate. And if you're an astronaut, who are all military now, and you're told that's where you're going, guys, they say, okay, so, and off they go. But they may be prepared to take the risk. And they obviously all survive because they all got back alive. But the one thing which cannot lie, because it doesn't know it's not supposed to record it, is photographic film, which is also affected by radiation. You may recall a few years back when security was introduced at airports, you were told best not to put your cameras through the X-ray machines because it may well damage the film, get them hand searched. Well, if a few X-rays in an airport security machine can damage photographic film, what's it going to do in space? It's not going to damage them at all, because the films that came back had no radiation damage whatsoever. And if you believe that, you believe in flying pigs, because it doesn't make sense. Okay, let's have a few pictures. 1961 was when the Apollo program was introduced by John Kennedy, as he was president then, May 1961. We will send a man to the moon and return him before the decade is out. We'll send a man to the moon and return him safely to the Earth. This was 6 weeks after Yuri Gagarin had successfully orbited Earth in April 1961. So Kennedy had to do something. I mean, politically, he was in a real cul-de-sac on this one. There's Johnson, there's Warren. Johnson may have had something to do with Kennedy being knocked off, and Johnson is Texan, and that's where the Space Command Center was, Houston. So we got the whole thing neatly tied up, and Warren conducted the inquiry, which exonerated everybody but Oswald. We're not going to get into that today. Next picture. But that was the start of the Apollo program. Now what you're going to look at is what happened, the context of the Apollo program. Height of the Cold War with USSR, as they went there. Height of the space race, which America was comprehensively losing. America managed to blow its rockets up on the ground, and Russia managed to get most of them up in the air. Vietnam War, which America was comprehensively losing, or about to lose. So we had a bit of a diversion from that, and in order to make sure the anti-war protests, which were going on, which were going to be starting in the early to mid-60s, and then of course we have all the assassinations, John Kennedy, Robert Kennedy, Martin Luther King. The 60s were a bit of a rough time. It's best to have a bit of a sideshow to distract people's attention from what is going on. Not that much different from today, really. Next one. You've got to look at it in the political context of its time, and the fact that America had spectacularly failed to achieve anything in space, and Russia had achieved everything. This photograph, which I consider to be a part of one of the best series of lunar photographs ever taken, which was taken in the mid-1950s at the Lick Observatory in California. And as Peter has successfully pointed out, all the Apollo landing sites are visible. This is Sea of Tranquility, Apollo 11 landing site. This is the Copernicus crater. There are three major craters, the Tycho down here, Copernicus in the middle, and Plato, the dark black one at the top. Anytime you look at the moon, you can see more or less those features. Next slide. Remember this crater here, it's the Copernicus crater. Now in the mid-1960s, America launched a series of 3 unmanned satellites to the moon. The Ranger, Surveyor, and Orbiter craft. They were unmanned and they photographed the lunar surface. Next slide, that's the Copernicus crater. The lunar orbiter was able to fly really quite low, about 15 miles above the surface of the moon, and this is a shot into the Copernicus crater. And it really does look like an impact crater, doesn't it? Flat bottom, 3-mile high side, 60 miles across. Now that's no impact crater. Well, if it is, it's a pretty weird impact. Impact crater is what we got in Arizona, meteor crater. Impact by a meteor. I don't know what this impact was. I suspect it was electrical. You ever seen an arc, electric arc, will make craters in metal. Round, flat bottom. This, I suspect, as were most of the large craters on the moon made by electrical discharge, not impact. Because, think about it for a minute. You've got the Earth, you've got the moon. The moon is tiny compared to the Earth in terms of space. It's also relatively close to the Earth in terms of space. You get a meteor, an asteroid, a local stray rock looking for a planet to hit. And it's tracking through space at 40,000 miles an hour, being attracted by the gravity of the sun, the attraction of the sun. And it happens across the Earth-Moon combo, which is doing its permanent circle in space. And it's coming from wherever, it doesn't matter where it's coming from. Which of those two objects is it more likely to hit? The Earth or the Moon? Think about it. The gravity of the Earth is much stronger than the gravity of the Moon, it's 6 times stronger. The size of the Earth is much bigger than the Moon. Any self-respecting asteroid is going to say, I'm going to hit the small one. No. Physics will tell you it'll hit the large one, Earth. So how come we've only got 200 impact craters that we found on Earth and 350,000 counted on the Moon? And how come there are so many on the face of the Moon towards us? Which means this asteroid has gone past Earth, missed it completely, and hit the Moon. Whoops. Doesn't make sense. Anyway, next one please. There's an illogicality about it, but there is much more logic to what the Russians had done in space. Sputnik, first satellite. They were first to the moon in 1959, with Luna 3, I think it was. They were unmanned craft to Mars, unmanned craft to Venus. They put the first man and woman and dog into orbit. They had the first spacewalk. They were getting there. Next one. America were nowhere. America do not have the option of coming second to anyone. One of the photographs that the lunar orbiter returned from the moon is this one. It's part of the photograph. It's the rolling rocks in Enderby after it. This is taken in the southwestern lunar orbiter, virtually photograph the whole lunar surface. These strips here, because they used strips of images that were transmitted back to Earth, they've got the strips and just assembled them into form of a picture. These objects here, we'll call them rocks for want of a better word. There's a big one down here, there's a smaller one up here. And then left, which look like a track. And the dark areas are craters, or areas below ground level. And the lighter areas, the sun is up the top of the picture. See the shadows here? This is supposed to be about 75 feet across. This is about 25 feet across. NASA asked to explain this, and they said, these are rocks dislodged by moonquakes moving across the lunar surface. Fair enough. There is gravity on the moon, by the way, and these rocks have managed to climb up out of these lower areas and wander along the surface for a few hundred feet, and it hasn't dislodged this rock, or this rock, or this rock, or this one, or any of the other rocks in the picture at all. It's only managed to dislodge two of them, which have left a pretty strange shape. I don't know what they are, but you will never see this photograph discussed. And regrettably, though I have spoken to Peter about it, astronomers, I've never ever seen this photograph reproduced in an astronomy book or magazine. It's as if it doesn't exist, because it doesn't fit the paradigm. And NASA never returned to the Vitello crater to re-photograph it. But there is now a satellite orbiting the moon called a smart satellite launched by the European Space Organisation, which hopefully will return a photograph of it. And I'm not holding my breath. There's also a pretty weird thing down the bottom here. I think it's a registration mark on the film, but I think it looks like a Spitfire. But really bad. I can't prove it. Next slide. So it's possible to read into photographs some things which are not necessarily there. You just push it down and read it. Now, if you're going to go to the moon, we're talking about the mid-1960s. We've had a look at the surface of the moon. You know roughly what the moon looks like, so you're going to do some simulation. Because when you're training anybody, airline pilots will get into simulators so they can simulate what happens when all four engines cut out at 30,000 feet. And if the thing crashes, it's best if it's not done with you on board, but them on the ground. So they'll make a simulator of the lunar surface, and here is a section of the lunar surface, and anyone who's worked in the film or television industry will tell you that this is a tracking rail for cameras to be pushed forward on to make it appear as if it is approaching, in this case, the surface of the moon. Here is a 20-foot line model of the moon, which currently is in San Francisco, if anybody wants to go see it. And this is an even more detailed version of the lunar surface. Nothing wrong with this at all. It's exactly what you'd expect people to do. Next slide. And if you watch the Tom Hanks version of the Earth to the Moon, you'll see that they actually use this to project outside the windows of the models in which the astronauts are practicing the landing on the lunar surface. And you see how much effort was put into it. There's a couple of people there. This is part of the Sea of Tranquility, which is a reasonable thing. Now, if you want to see a full-scale model of the Sea of Tranquility without going to the moon, you go to Flagstaff in Arizona and you'll find one there. It's about 2 miles long, it's about 1 mile wide. It was created in the volcanic part of Arizona by the US Geological Survey, and took a map of the proposed landing site, the Sea of Tranquility, and created some craters. They call them sticks of dynamite. And they made it, and it looks rather impressive. If you fly over a helicopter, it looks like you're on the moon. You watched the TV show Planet on the BBC a couple of years back, we showed it on that. Next slide. So there's nothing wrong with creating as close to the environment that you're going to as you can. And you create spacesuits, and you practice using collecting your contingency sample rake. This is Neil Armstrong. You can see that he's not on the moon, he's in a warehouse, but practicing on his deported lava bed. This is any control like he does on the moon. Next question, next slide, please. So if we're going to go to the moon, we're going to need a huge great rocket. And here we have our huge great rocket, the Saturn V rocket, Hypers and Falls Cathedral, and the astronauts, and there were 3 of them in the top. And this did go off, and it was 365 foot high, and it did make a heck of a racket, and lots and lots of people watched it, as they did all the launches. Oh, by the way, at 12 o'clock tonight, ITV, they showed Capricorn 1. Again, I think it'll be what we're going to do tonight. But isn't it strange that 2 of the stars marry Barbara Streisand, and one of them is trying to know? For the day. We're going to Mars, we're going to the moon. This rocket, you'll notice, just to give it a little bit of its history, it has the black and white rectangles on, which are carried over from the V2 rockets aimed at London, and hit London, 1,000 of them. Developed by a certain Werner von Braun, who was an SS Nazi officer, who was rescued, or rather surrendered to the Americans, and in Operation Paperclip was brought over along with 100 other SS officers to work for the American space program. Such nice people that they developed the American space program. Next slide. When you're going into space, we've already mentioned the radiation belts. Here they are, held in place, as I said, by the Earth magnetic field, extending about 40,000 miles out. There's 2 of them, the inner and outer. That's the inner belt there, and the outer belt extends a bit further out. There's actually a 3rd belt now, at about 250 miles up, so 250 miles, created in the mid-1960s under what's called Operation Starfish Prime, where the dear old Americans decided to see what would happen if they exploded a 1 megaton, that's 1 million ton, nuclear weapon, 250 miles above the Earth's surface. It went bang, and it was supposed to blow a hole in the atmosphere to let all the heat out and stop global warming. That, by the way, is Alternative 1. Alternative 2 is build underground cities. Alternative 3 was a TV program and a book where they colonized Mars and the moon. But it got close enough to the truth, and nobody realized how close it was. Alternative 1, blow a hole in the atmosphere, let the heat out, actually happened. And then the Russians, not to be outdone, did the same thing over Siberia. Now, if you set off a nuclear weapon, guess what? It leaves nuclear waste in the upper atmosphere. Is this why nobody went into space for 18 months after that happened? Is this why space is such a dangerous place? Is this why the Americans and the Russian military are complete fruitcakes? And Dr. Strangelove, the film, underplayed it severely? I think so. Next slide. Sorry, I get a bit political sometimes, so I should. This is a science lecture, allegedly. And then we look back at dear old planet Earth. Oh, what a lovely place. There's Saudi Arabia, it's the Red Sea, Africa, Madagascar, Antarctic, Australia around the corner here, Mediterranean up here. And this, ironically, given the vast number of hours that everybody spent in space, allegedly, is the only photograph you'll ever see of planet Earth taken from space. It's the only one. It's a very good one. And you can tell which one it is. Look for that little white feature there, which is Julie Cloud, over, what country will that be? Kenya, probably, or Southern Sudan. And watch for the swirly bits here, and Madagascar and Ethiopia. It's the only one. For why? They had so many cameras and so many rockets and so many people went up there. It's the only one they took. But you always hear this, they were so good at photography, they could train for months. They could do it with their eyes closed, which is what they did. They did it with their eyes closed. I'll show you why later. Next slide. As we get near to the moon, you can look back at our pale blue dot floating in space, and you can get seriously romanticised and emotional, and you can set up Greenpeace or the environment movement started because of this photograph. Poor defenceless little planet Earth. Oh, that photograph, by the way, is a complete fake. It's a fabrication. Do you know why? Okay, bit of science. If you're orbiting the moon, as you appear to be doing in this photograph, you're flying about 60 miles above its surface. So those mathematicians here are going to tell me how far away the horizon is of a planetary body which has a diameter of 2160 miles. And the answer is 250 miles. A bit of trigonometry will tell you that is the horizon. And this photograph, 60 miles, we're told it was taken on Apollo 8, which didn't land, it orbited, allegedly. The highest mountain on the moon, we're told, is Mount Hadley, at 15,000 feet. Let's call it 3 miles. So what we're being asked to believe here is that this mountain, I don't know if it is Mount Hadley, but we'll assume it is, for sake of argument, is a 3-mile high mountain, which you're looking at from 250 miles away. Is that logical? It's you standing on top of Blackpool Tower, assuming this is possible, I haven't worked out the mechanics of it, and looking at the Eiffel Tower and seeing it 250 miles away. Alright, forget the mist and the shit and the muck and the atmosphere. Assuming you could see the Blackpool Tower from the Blackpool Tower, what would it look like? So, you wouldn't get a bumpy horizon, is the point I'm making. You would get a flat horizon. You look at any photograph taken from the space shuttle or the space station above Earth and look at the horizon. I know it's got an atmosphere, I know it'll be diffused, but it's flat. It's completely flat. So actually, this photograph is a double exposure of the model of the moon, currently in San Francisco, a photograph taken of Earth, and probably know how far away. How do we know that Earth looks like that? I don't know. Maybe it does. It's got white fluffy clouds. It's got blue seas. It's got a bit of brown land. Could be a model. There's no proof it isn't. Right, there's no proof it is. Next slide. So if you're going to take photographs in space, how are you going to do it? You're going to have a camera. You get the best camera you can. This is the camera. The Hasselblad lunar camera. And this is the camera that you can walk into any photographic shop today and buy. They got it right the first time, the 500 EM, electric motor drive. That is the shutter button, the little button on the front. We'll come back to that. The viewfinder is in the top. You look down into the viewfinder. It's a single lens reflex. It's a mirror, and you look through the lens. And it's a very, very good camera. It's designed for studio work. It's designed to be used on a tripod. It's not designed to be carried around. That's what we use 35mm cameras for. The lenses are the best lenses you can buy. They're made by Zeiss in East Germany. And the lunar camera has electric motor on the bottom, a large magazine at the back carrying over 100 exposures and colour film and 200 in black and white. Next slide. So I got to look at this replica, a replica of the lunar camera, and this is what it looks like. Very similar to the ones that appear in the photographs allegedly taken on the moon. And the points to look at here are, this is the only indicator on the camera that you have taken a picture. Now, normally when you take a picture, it goes click, work. And you know you take a picture. If it goes, you know, what's that? Battery flat. On here, you can't see that counter from inside the spacesuit, because this is going to be mounted on your chest, right here. Underneath here is where the battery is. Next slide. Now, here are the batteries. The two of them are D-type, ordinary top battery made by Varta, Germany. That's the indicator there, to the pictures you've taken. In space, there is no sound. You can't hear a mirror going bang. There wasn't a mirror inside. Anyway, batteries here. Right. Have you ever tried starting your car and the battery's a bit weak, it's a bit cold? Don't work. These batteries worked thousands of times. Do you know how many photographs were actually taken on the lunar surface and all the alleged Apollo missions. A couple hundred, 5,771. And I've counted. That's how many photographs were taken on the lunar surface. Every time these batteries work, they didn't change the batteries, change the magazines. You ask any battery manufacturer, what is the temperature range of your batteries? And they'll say it's minus 20, minus 30 degrees centigrade, up to about 50, 60. 50, 60 is not a problem. I'm sorry, batteries like that don't work in cold temperatures. They don't hold their charge. Next slide. But we're told they did. So anybody who says the photographs showing the Apollo missions were taken on the lunar surface is going to have to explain that, how the batteries work. I've asked Varta. They gave me that answer. There's no exposure meter. It's not an automatic exposure camera. This is the only exposure information. If you can push it up just a little bit. This is the only exposure information the astronauts had available to them. There's a little sticky bit on the back of the magazine. So if you pointed it with your back to the sun, there's the sun. Back to the sun, you put it on 5.6, you get this. And on here is where you set the aperture, shutter, and focus. And you do it all manually, by hand. There is no automatic focus on these cameras. There's no automatic exposure on these cameras. You set the shutter, you set the aperture, you set the focus manually with no viewfinder, because you can't use a viewfinder. You've got a space camera. You can't look into the camera. Next slide. So anybody who's going to say that these photographs were taken on the lunar surface is going to have to explain a very great deal about the photographic equipment. There's no viewfinder, no exposure meter, manual setting of focus, aperture and shutters. There's no additional lighting other than that from the sun and its reflections, because there's no secondary lighting or reflectors carried on the Apollo missions. Next slide. So what you've got is a pretty simple setup. But first of all, you've got to get there, and this is how you land. You land in the lunar module. It's in two parts. Top part where the astronauts are, bottom part, the engine is slowing it down. Don't worry about all the technical details. All you need to know is that both of them stand in the top. There's only two go down on the lunar surface, and they slow the thing down out of lunar orbit. Lunar orbit speed is 3,600 miles an hour. They've got to get it down to 0 or whatever. Dead. So they use this rocket here to reverse thrust to slow it down. Logical way to do it. Stupid, but logical. Because stupid, I say, because nobody had ever flown one of these things before. Armstrong was probably the most experienced pilot of them all, and he had real trouble controlling on the test rigs, and the films have been crashing. Well, he ejected, the thing crashed. So they got this rocket. The rocket is rated at 10,000 pounds of thrust. That is the same power as a Harrier jump jet. If you've ever seen films or even seen a Harrier jump jet land or take off, which is what we're being asked to believe this did, if you've ever seen a Harrier jump jet land or take off, you'll know that it's not bolted to the ground within 100 yards of it coming down and fly away. And it makes one heck of a racket. Rockets don't have silencers, but in space, you can't hear it. Good thing. Next slide. So you're going to land this strange contraption on the lunar surface, which has never been flown and landed successfully on the lunar surface or anywhere. And these are the controls that Armstrong had available to him. This is the triangular window he would look out on. And that's the control stick. Now you may recall a wonderful dramatic account that NASA gives of Armstrong, big brave hero Armstrong, one for that, who had to take over manual control of the landing of Apollo 11 because the computer had shown an overload, a 12:02 warning. 12:02 warning is the radar telling him how far he was from the ground, couldn't pick up the information because there was too much dust flying around. So it indicated an overload and it said, get out of here. Armstrong got the right stuff, said, forget the computer, I'm going to do it by myself. took over manual control and landed it. Big hero. He's never ever spoken about that. Never ever spoken or given an interview. He's a very private man. Anyway, this is the control that he was using. These are the switches, and you may recall the famous video sequence of the Apollo 11 landing. And all you hear is a sequence of numbers. It's Aldrin's voice you hear. And Aldrin is reading out from his similar panels over here. Number of feet down, number of feet forward. So we're trying to get down. And Armstrong was saying, hey, big boulders here, we're going to move on a bit, we're going to go somewhere else. And they flew about 2 or 3 miles beyond the agreed landing site, and they almost ran out of fuel. Another dramatic twist to the story, big hero. Next slide. So, think of that commentary, think of that video sequence of Armstrong landing. All you hear in the words, you don't see them, this is what they look like. And you look out of the window and you see the ground getting closer, and you see Gus being kicked up a bit, and contact, and the Eagle has landed, and Houston says, thank goodness, we've got a bunch of guys about to turn blue here, because they're all getting very overexcited. Okay, question. Armstrong Aldrin. This is a simulation shot. This is not for real. This is simulation. This is the control panel, and his right arm is on that control lever, and these are the switches and dials that he is operating. This is the landing control panel, and in front of him on his left hand here is a keyboard. It's not a full computer keyboard, but it needs to enter information. Would you trust your life to a computer keyboard if you had to wear heavy-duty gauntlets to do it? Okay, that's what we're being asked to believe. Because you could hear what they were saying when they landed. And you could hear it because they must have been wearing their spacesuits. Because if they weren't wearing their spacesuits, and you don't wear half a spacesuit, you wear it all or nothing, you wear helmet, gloves, and the like. If he wasn't wearing a spacesuit, he was standing on top of a 10,000-pound thrust rocket, which makes a bit of a noise, and because he wasn't wearing a spacesuit, the atmosphere inside the lander had to be pressurized. In an atmosphere, sound travels. The bottom half of the lander was bolted to the top half. It would vibrate it, but you didn't hear that. So he had to be wearing a spacesuit, because you couldn't hear the rocket. And if he was wearing a spacesuit, how did he operate these very small dials, switches, buttons, and keyboards? He did it in a simulation. This is a simulation. If he was simulating a real landing, and they did supposedly have their spacesuits on when they landed, why did they simulate the whole thing without the spacesuits? That's the first major anomaly about the landing, and anybody who says Armstrong landed as we were told he did will have to explain that. You could hear him. He controlled it manually on this control panel with a spacesuit. Next slide. Alright, we landed, obviously, because it would make a story if we had. We're on the moon, and these are the conditions of the moon. It's in a vacuum of space. The temperature range of sunlight is 250 Fahrenheit, higher than body of water, to minus 250, colder than anywhere on planet Earth. No protection against radiation, only one light source from the sun, and the lunar surface has an albedo or reflectivity of 7%. I was glad to hear Peter acknowledge that the Mars, the seas, the dark areas, have a lower reflectivity from 7% down towards 3% on sunlight. Alright, you don't need a lot of light reflected because the sun is very strong, so they can't look directly at it. Next slide. So bearing all this in mind, the restrictions on the camera equipment, we're now going to look at some of the iconic photographs of the 20th century. And I want you to ask yourself as you look at each one, how did he do it? Here's Aldrin coming out of the hatch, backwards on his tummy. Next slide. And the next slide move on a little bit further down. There's the hatch, that's the porch onto which he's sort of scrabbled backwards. And you'll notice that there's a triangular window that Armstrong would have looked out of to land the craft. And here's Aldrin, obviously very happy because he's throwing his left foot up in the air. And this is the lunar surface, which is directly illuminated by the sun. And this area here of the lunar lander is in shadow. You'll see it on the next one. Take my word, this is in shadow. It's not directly illuminated by the sun. So where did all this light come from? Looks like a spotlight, doesn't it? Or a reflector. Ah, no, oh, it's a reflection off the lunar surface. Correct. Frankly, it's not. There isn't enough light to reflect off the lunar surface and be recorded on Kodak Ektachrome film. That's the key point. You have to know how photographic film works in terms of recording light. The film used in these cameras, we're told, was transparency material, Kodak Ektachrome, which anybody who's tried to take a photographic slide, I think this is well before digital cameras, anybody who's tried to take a photographic slide and got the exposure wrong will know there's absolutely nothing you can do about it in the processing, the development. You can't push it, make it come out if you've overexposed it, underexposed it. You process it as it's designed to be processed. So you can't alter the way in which it comes out of the camera. You can alter it on print. When you take colour prints, or negatives, yes you can alter it. Not on slides, and these are on slides. So where did all this light come from? It's not reflection off the lunar surface. It's not earthshine, reflection off Earth, as you get moonshine, because as any astronomer here will tell you, if I ask the question, you're standing on the lunar equator, where would you look to see planet Earth? You know? Directly overhead. Think about it. You're standing on planet Earth, you're looking at the moon, what do you see? Assuming it's a full moon, you see the full moon. It doesn't drop 5 degrees of libration, it moves a little bit out of vertical, but not much. So if you're standing, as they were alleged to be, on the lunar surface, planet Earth is directly overhead. So it can't possibly be that. The only other explanation for that amount of light is a flash located directly next to the camera. And mathematically, that can be demonstrated. The clue to that is that highlighted light on his heel. Highlighted light on reflective surface is only produced by a point source of light. Think of the sun reflected in a helmet. It's a point source of light. If it was a big reflector, it wouldn't produce highlighted light. And it's a flash gun for one reason. Who spotted it? His foot's not on the ladder. His foot's moving. His whole body's moving. He's jumped, completely blind for the first time. Bit of an idiot, sort of, frankly. He's jumped off this porch thing here on to the top rung, which he can't see. Brave lad, got the right stuff, obviously. He's thrown his left foot out, so it doesn't matter if he misses, he just slides straight on the back. There's one problem with this picture. If you look at the video sequence of the same event, his left foot goes nowhere out there. He's like anybody coming down the ladder. You keep your feet pretty close to the ladder. But no, it's much more photographically exciting. This photograph, I can tell, was taken under controlled studio conditions on planet Earth. Nowhere near the moon. Next slide. As was this one. Same sequence, coming down the ladder, lots of fill-in light, lots of illumination in an area which should be completely in shadow. The door through which they just come out, and the next there's the top rung. All these highlights of light indicate at least some form of light source close to the camera, which they didn't have. There was no additional light source carried on any of the televisions. Next slide. So, when you start looking at it, knowing the limitations under which they were taken, and here we have the one small step for me, one giant leap for everybody else picture. Well, what was all this? you'll notice that there is no photograph of Neil Armstrong on the lunar surface. Anybody ever seen a photograph of Neil Armstrong on the lunar surface? You can prove it conclusively by the lunar shadow down. No, you haven't. Because Aldrin refused to take his photograph. We're not going into why. This is Aldrin's boot. And think about it, you've got a camera on your chest, allegedly. You've now got to focus it on your foot, which is about 3 foot from where you can hold the camera. And the Hasselblad only focuses down to about 3 feet. And you've got to get it right first time with no viewfinder, no exposure meter. Come on guys, you're going to believe that? Any photographer will tell you that's your commission to photograph a foot showing a footprint in a soft soil. How many photographs will you take to get the exposure right, the focus right, the composure right? Let's say, give me a couple of rolls of film, I should be able to get it done. It's 24, 25 pictures. No, one. That's all you're allowed. No, can't do it. You ask any professional photographer, the cheapest thing they've got is film. Their time is what costs money. These guys could produce the impossible under impossible conditions every time. They surely have the right stuff. Next slide. It's the only picture of the boot. And here we have the famous classic Aldrin man on the moon. This is Aldrin, not Armstrong. It says Aldrin on here, that's why you know it. And, oh, a wonderful picture. Everybody's familiar with this. Complete fabrication, of course, taken on very controlled studio conditions. Alright, why? On the moon, we assume that NASA are intelligent enough to be able to work out on a planet with the diameter of 2,160 odd miles, how far away the horizon will be when you're standing on it. It's about 1.5 miles. So, this is about 1.5 miles away, allegedly. Here we have an astronaut wearing a full spacesuit but no camera, and the sun is, as you can see, behind him and to his left and right. And we can see where the lunar lander is, it's to his right also. So what is it that's to his left that is producing the reflection that allows this amount of sunlight or light to go into an area that's in total shadow? Because the whole of his right-hand side is in shadow. If the only illumination source is the sun, which we can see highlighted on the left-hand side and down here, reflected off there. Now, when you take a photograph on Earth with the horizon the best part of 6 miles away, and you photograph, let's say, some flat area with this sort of surface, you would expect, when using a camera with a normal focal length lens, or a wide angle, as this was, a slight wide angle lens, that if you've got the foreground in focus here, the background will be in focus as well. It's just optics. There's no big deal about it. That's the way cameras work. You focus on the central part here, the background will be in focus. On this camera, it's a 60mm lens that we're using, we're told. So what's the background doing? Out of focus. The background is out of focus because this was using a telephoto lens. It's the only way you get that input. The telephoto lens wasn't carried on Apollo 11. This lot is all in focus here, and it's amazing how dark the shadow is when they want it to be, and how light the spacesuit is when they want it to be. Next slide, please. So you've got these little anomalies going on. There's one more point about this picture. Similar one. This is Aldrin with the flag. And you'll see here that this is got enough detail in the spacesuit to see what it is. But surprisingly, in the spacecraft, the lunar module, suddenly you don't need to see it, therefore there is no light in there. Oh dear. And this cable here where it goes to the TV camera, we're told, is not going to the lights. But what we do have a problem with on this picture, you can just move it up please, just move it up, is the one-legged astronaut on the moon. What's that footprint doing? You see these footprints here, there's two of them, and they go in line. But this one is right on its own, all on its own. It's only one footprint, going left to right. There's no footprint behind it, there's no footprint in front of it. Where did the one-legged astronaut go? I don't know. Because it was a set person. It's old. It's got a picture. Next slide. Now if you look at two pictures together, the two previous ones we looked at, man on the moon, ordering with the flag, and look at the position of the horizon in relation to the astronaut. In this one it goes through his chest, and this one it goes through his head. How come? If the photographer was the same in both cases, Armstrong, we're told, had his camera mounted on his chest in both cases, we're told, the horizon on the Sea of Tranquility, we're told, was a flat place, therefore the horizon, there won't be any hills anywhere nearby, and it's only a mile and a half away. They didn't land in a place with hills. The only way you'll get that difference is when if the camera is held at eye level in one picture, this one, or chest level on this one, you try it yourself. The horizon will move in relation to the subject, depending on how high or low the camera is. That's it again, it's optics. Next slide. You have to take with different cameras, different lenses, not lenses. And here we have the famous pool of light. Look how bright this area is relative to the background. Illuminated from the sun, the whole of that should be at the same light level. What you get on Earth, it's the same light source, the sun. It's all dark and dingy. Here it's very bright, here it's dark and dingy. It's a follow spot, probably a 5K spot, illuminated. Next slide. And by the way, you don't get stars in these pictures for the simple reason, as any photographer will tell you, that the exposure required to illuminate, to photograph something in the foreground is far greater than the exposure required to record the stars as they would appear in the sky. And that's what obviously they're there. Where was the photographer? Where was the camera that took this picture? You're looking down on Aldrin, you're looking at the top of his helmet, the top of his backpack. This is the solar wind experiment. Solar wind experiment is a sheet of aluminium unfurled to record particles from the sun, cosmic solar wind. It's solid. You can see from the shadow it's solid. So where's the light coming from? It illuminates it. And because the shadow cast by the pole holding it is sharp, it's a point source of light. It's not a reflector. But there shouldn't have been a reflector there in the first place. I don't know what this is. Let's not go there. Again, pool of light, horizon out of focus, horizon dark. Photograph on Earth, under control, or rather not, under control studio conditions. Next slide. So you've got the picture here that there is something a bit amiss, and there are questions that can legitimately raise about Apollo. And here we have a very weird picture. It's taken from Apollo 11. It's taken from the data acquisition camera. It's a cine camera mounted on the craft that filmed at 1 frame per second the whole time they were on the surface that they recorded. It's a bit jerky. But here they are with their flag, American flag. Armstrong, Aldrin. They're both made of about 6 foot, so they're both about the same height. So how come their shadows are different lengths? Shouldn't be different lengths. And if you do the trigonometry, you can calculate the sun angle to produce that shadow. And we saw from the original, the earlier picture of the Aldrin with the flag, it's completely flat in that area. There's no big hill, a big dip. It's flat. If you do the trigonometry, this angle here is 35 degrees, this angle here is 26 degrees. Both of which are wrong. They landed, we're told, when the sun is at 13 degrees above the horizon. So we can't even get that right. But how we get two people at the same height with different shadow lengths, I don't know. A bit of a mistake there. Next slide. Again, it's a question that needs to be answered adequately by NASA. It may well stand for not always scientifically accurate. And here we have the big giveaway. Aldrin, Armstrong. Astronaut Edwin Aldrin inside the lunar module after his blue ball. This is a book bought at the Kennedy Space Center in Florida. So it must be for real, published by NASA. I'm sorry, this photograph was not taken inside the lunar module. It may be taken inside the lunar module, but not after his moonwalk. Because who took it? Well, Armstrong, obviously. The only camera he had crosshairs in it. How did he focus it so accurately on Aldrin's face that the background, a few feet away, was thrown out of focus, and how did he know that? There's only one picture taken. He's putting his shades away at this point, and you notice the reflector reflected in it, and the highlights of light in his eye indicate the light source close to the camera. We move the picture up a bit, and look at Armstrong in the same situation. The highlights of light in his eye indicate the light source close to it. Look at any press photograph, they're always taken with flash guns, you'll see a pinpoint of light in the subject's eye. That's what causes it. And any photographer will tell you that if you put a light close to the camera, you get guys smiling, you're quite likely to get reflections off the teeth. Armstrong had his teeth done, so they reflect. Who took it? Aldrin. With what camera? Not one was carried on Apollo. These were taken during the simulation exercise. So why tell us it was inside the lunar module as it rested on the lunar surface? NASA are lying again. They don't stop lying. They just carry on making you believe something that they want you to believe, which is scientifically complete nonsense. What tells me I have to stop? Thank you.